Welcome dear subscribers to this video tutorial that will guide you on how to blink a LED continuously or infinitely using Arduino and Proteus. In the previous tutorial we saw how we can turn on and off a LED. So here we are going to focus on blinking the LED. So connect your circuit as such. Here we are utilizing pin 7. You can use any of the digital pins. Then after connecting your circuit, we move to the coding aspect and we are going to see two strategies on how to do so. First strategy is using the void loop function, which is highlighted as such. In the void loop function, you're simply going to put in your code here to turn on and off the LED. Since it is in the loop function, the loop will continuously execute it. Immediately it executes from beginning to end. It starts repeating it back from the beginning. So that's the function of the loop. Then the second strategy is using the void setup function. Here, the void setup function is not a loop. So if we are turning on and off the LED, it's going to execute it only once. So for us to infinitely turn on and off the LED, we have to create our own loop within this setup function. So let's proceed with the first strategy. First of all, we have to configure the output pin 7. Since pin 7 is an output, we use the command pin. Our LED is an output, we use the command pin mode in bracket 7 output. So we have configured pin 7 as an output. Then we can now proceed to the void loop function. To turn on the LED connected on pin 7, we use the command digital write. Please, these commands are case sensitive as such. Digital write in bracket 7 high. High signifies 5 volts at the output of that pin to turn on the LED. Then we delay by 1 second, which is equivalent to 1000 milliseconds. Then we turn off the LED by using the command digital write. At pin 7, we turn it off by giving a low state, which signifies 0 volt at the output of that pin. If you end your code here, when you run the simulation, you will see that the LED will not be blinking. The LED will just show it's on continuously. This is because the microcontroller is too fast in processing. It's very fast. Immediately it is turning off, it is turning it on back. So you will not see the effect of it turning it off. If you want to see the effect of the LED going off, you need to give another delay here. We give a delay of 1 second. Take note that you can configure your own delay time, so it can be modified. Then you verify to compile. Done compiling. After compiling, you have to look for the hex file to load it within the microcontroller. I showed you in the previous video on how to locate this and load into the Arduino. I showed you two strategies. So if you haven't followed that, please, you can go to the previous tutorial and see the various two strategies on loading the hex file. So this is one of the strategy. You copy from C to .hex by using the command Ctrl C on your keyboard. Then double click on the microcontroller and then you paste it here. Okay, then you can now run the simulation. You see that it comes on, goes off, comes on, goes off continuously. So it will keep doing this infinitely. It won't stop. I showed you how to calculate the value of the resistor that is used to limit the amount of current. Because if this resistor, the value is too high, it's going to block all the current flowing to the LED, and the LED will not perform whatsoever it has to perform by blinking, or it will not come on as such. Then the second strategy is using the setup function. So let's cut this from the loop function. come to the setup function, paste it within the setup function. Let's see how this will behave. The setup function executes the code only once, from beginning to end. Once it arrives at the end, it stops. For example, let's verify, and you see I'm not saving. If you want to save, you can save. Okay, it is done. If you are using the same file, you don't need to copy the hex file again to come and paste. You just simply simulate in Proteus. It's going to perform whatsoever has been coded. You see it has come on and gone off only once. So that's how the setup function behaves. So if you want to create a loop, you can use a while loop. So put in the command while 1. 1 is a condition there which signifies that it's always true. Then the operation has to enter within the braces of the while loop. So these are the braces of the while loop that we have inputted, the open and the close bracket here. Then run the simulation, run the compilation, compile, done compiling, then go and stop the simulation and run back the simulation. You see that it is blinking on and off continuously. So you can increase the blinking rate by simply doing what? Reducing the delay. For example, let's take 0.5 seconds, which is 500 milliseconds. Compile. You can save. Done compiling. So stop the simulation and run it back. You see that the blinking rate increases. It's clear, right? You can even reduce it to 0.2 seconds for it to be very fast. Compile. I choose not to save. You can save. It's done compiling. Stop the simulation. I run it back again. You see it's blinking now very rapidly, very fast. So this is how you can actually blink a LED using Proteus and Arduino. In our next tutorial, I'm going to show you how to blink a LED for a specific, or put on a LED for a specific number of times. For example, if you want to put on a LED 20 times or 40 times or 100 times and then it ends, you won't keep writing the command jitter right high, then you delay, you off 100 times like that. No, the code will be too long. So I'm going to show you in the next video tutorial on how you can use a very simple method to put on and off that LED for a specific number of times. Thank you, and if you haven't subscribed to this channel, please subscribe and like this video. You can share as well. If you have any feedback, please allow your feedback at the comment section. You can as well visit our website at ektechnologies.com to follow various posts on our publications and projects and articles that may be of great help and importance to you. Thank you very much, and stay tuned.